Here, let's watch a movie first. Attention everybody! There's a signal that the headquarters had received. Check on it.
On it, sir. Sir, we don't know this. This is beyond our knowledge.
I believe this is AC2, EBCDEC, and Unicode, the three common coding schemes.
What are those, sir?
AC2, or the American Standard Code for Information Integer. It is the most common character encoding format for the text on computer and the internet. Standard AC2 encoded data has 128 numbers, or special addition characters and control code specific values. Characters in AC2 encoding include uppercase and lowercase letter from A to Z. Numbers from 0 to 9 in basic punctuations. It also uses non-printable control character originally intended for use in teleprinter printing terminals. AC2 characters can be presented in the following. First is represented as a hexadecimal pair of radices 16 and 0 to 9, and A to F for a decimal value of 105. Second, 3-digit octal number or the radix 8. Third, a decimal number from 0 to 127. And fourth, as a decimal 7-bit or 8-bit binary. The second one is the EBCDEC or the Extended Binary Code Decimal Exchange Code is an 8-bit binary code for numbers and alpha numbers. It was developed and used by IBM. This is an encoding representation of symbols, letters, and numbers in any binary computers. This encoding widely used in IBM midrange. It was developed to enhance the existing functionality of binary coded decimal code. The last one is the Unicode. Unicode was developed to solve the problems caused by the rich code set. Hundreds of encoding have been developed since dawn of computer programming, each with a small group of languages and for a specific purpose. Therefore, interpreting, typing, and sorting, and displaying, and also saving text depends on your knowledge of different types of character sets and their encodings.
Do you know binary codes? Those were the simplest forms of computer code and programming data. It represents text, computer processor instructions, and any other data using two symbol system, which is 0 and 1 from the binary number system. The binary code assigns a pattern of binary digits, which is also known as bits in each character, instructions, and etc. Computer applications, binary numbers are represented by only two symbols or digits, which is 0 and 1. The binary numbers are expressed in the base 2 numeral system. And those binary data are stored in a binary file, where it is a type of computer file that is used to store binary data. It may contain any type of formatted or unformatted data encoded within a binary format.
Oh yes, and then the smallest unit of the information in a computer is called the binary digits, or the bit, wherein it is the smallest unit of the binary information recorded in a computer system. A bit can only have two states, on or off, which are represented by ones and zeros. Which information is fed in and processed by the computer is determined by the combination of ones and zeros.
Okay, let's watch again.
So, this here is an integer, a data type that represents some range of mathematical integers. In a computer, the integer data types contain whole numbers with accuracy of 9 or 10 digits that range from negative 2,147,483,647 to 2,147,483,647. So this data is a reserved number that cannot be utilized. The integer value is a signed binary integer that is commonly used to hold counts, numbers, and other similar data. So, an integer is represented by a fixed number of bits in computers. The 8-bit, 16-bit, 32-bit, and 64-bit integers are the most popular bit lengths. In addition, there are two representation strategies for numbers, the unsigned integers and signed integers.
Yes, and those are the bytes and octets. So, byte is a unit of memory data equal to either 7 or 8 bits, depending on whether or not it needs error correction or parity. So, you can think of a byte as one letter. For example, the letter H is 1 byte or 8 bits, and the word hope is 4 bytes or 32 bits. So when looking at the size of a file, a byte is the smallest measurement size listed in operating system. While on the other hand, an octet represents an 8-bit quantity. So octets range in mathematical value from 0 to 255. So the term octet is also used in other contexts such as musical performance to refer to a group of 8 people or parts. Also, a word is a term used for small group of bits that are handled simultaneously by processors of a particular architecture. So, a word can contain a computer instruction, a storage address, or application data that is to be manipulated. So, for example, added to the value in another word space. So, in some architecture, a double word or larger unit is required to contain an instruction, address, or application data. So typically, an instruction is a word in length, but some architectures support half-word and double word length instructions. So many different word sizes have been used, including 6-bit, 8-bit, 12, 16, 18, 24, 36, 39, 40, 48, 60, and 64-bit.
Sheila, what is the short and long-term integers?
A short integer can represent a whole number that may take less storage while having a smaller range, compared with a standard integer on the same machine. In C, it is denoted by short. It is required to be at least 16 bits and is often smaller than a standard integer, but this is not required. A long integer is a data type in computer science whose range is greater or sometimes even double than that of the standard data type integer. Depending on the programming language and the computer machine processor, the size of the long integer will vary. In some programming languages, the size of the long integer is standard and fixed across different platforms, while in others, it depends on the processor. There are certain programming languages that do not make us use of long integers, but they are used in many programming languages for holding a long range of values, especially during mathematical computations. The binary number system contains two unique numerals, 0 and 1. The system is thus a base two-number system. The relative magnitudes of the symbols were 0 less than 1. The symbols in the system are often referred to as binary digits or just bits. And in the octal number system contains 8 unique numerals, the 0, 1, 2, 3, 4, 5, 6, and 7. And in the decimal number system has a base of 10 because it uses 10 digits from 0 to 9. And in the hexadecimal number system contains 16 unique numerals since there are only 10 Arabic numerals in the decimal system. We need to use other symbols to represent the remaining 6 numerals. We use the alphabetic characters A to F. In order to expand the system to 16 numerals, the 16 numerals in the hexadecimal systems are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then A, B, C, D, E, and F. And on the operations on the binary numbers, it includes the 4 basic arithmetic operations of addition, subtraction, multiplication, and division. First, in operation on binary numbers, there's rules wherein 0 plus 0 equals 0, 1 plus 0 equals 1, 0 plus 1 equals 1, and 1 plus 1 equals 10, and 1 plus 1 plus 1 equals 11.
Or do you know that aspect on the computer designs that concerns the fundamental operations and structures upon which all computer systems are built?
Computer logic? Why?
Because any arithmetic operation in a computer system can be implemented using the basic logical informations, such as and or. In fact, it has been proven that an entire computer system can be designed and implemented using solely NAND. These logical operations have truth tables that enumerate the output signals for a particular combination of inputs. It is typically named A, B, and C, whereas outputs are typically represented as F, G, X, and Y.